Hi guys, so today we're starting a new unit on statistics. So statistics is the study of numerical data and we use it to describe characteristics of groups and to make predictions about those groups. So you want to make a prediction about a population of people. And by doing that, you can't possibly test the whole population, so you test what's called a sample. It's a smaller group of that population. So for example, a magazine company wants to know the average income of their readers, so they put out a survey. Or a drug company wants to know if a particular drug works to help children with asthma, so they test that out. Those are all examples of statistical studies. So you have there the definition of a population and a sample, which I described. And when you do a study, a statistical study, it's called sampling. The sample has to be fair. It has to reflect the entire population being studied. So you can't only look at boys or only look at girls. The sample must contain a reasonable number of items being tested. So you can't test on only a group of 10 kids. It would have to be tested on like hundreds of kids. And 3 random selections should be used in the study. So you should randomly select people so that it's fair and unbiased. So biased is when it's not a fair study. The typical statistical study has 3 steps. You collect your data. Then, because you have a lot of data, you have to organize it into tables and charts and graphs. And then we make conclusions on based on our data. So what we're focusing on in this lesson is organizing into tables, charts, and graphs. So all those different statistical tools are what we're going to look at. Qualitative versus quantitative data you guys have looked at in science class. Qualitative is qualities or categories. For example, like just rating as excellent or satisfactory or poor. Quantitative data is numbers, counting measurements. For example, keeping track of how many dishes a restaurant sells. Data can also be univariate or bivariate. Univariate, the prefix uni means one. So when you collect data for one variable, for example, how long do you travel to work? Or bivariate means 2 variables. So for example, you keep track of how much your sales are versus the temperature for an ice cream store. Those are 2 pieces of data being collected. So we're going to look at ways that we can organize univariate data in this lesson. Univariate, again, meaning one variable. We're going to look at frequency tables, histograms, stem and leaf plots, dot plots, and box and whisker plots. The frequency table, an example would be this. Student absences in 1 month for a class of 20 students. So like the 0 means that this person was absent 0 times. This person was absent 3 times, etc., etc. So you would go through and see, okay, how many kids were absent 0 times? So I have 1, 2, 3, 4, 5, 6, 7. So you do a tally, 1, 2, 3, 4, 5, 6, 7, and then you do frequency 7, which is the number that represents that. And you would do that for all of them. So how many people were absent 1 time? 1, 2, 3, 4, 5. So my tally would look like this, and my frequency would be 5. So frequency is the number of times that value appears. We're not going to do the whole table. So some frequency tables have what are called intervals. That means that instead of listing individual values, like in the example here of test scores, like you wouldn't want to tally up how many people got a 99 and 100 and 98 and 97, because the table would be too long and difficult to read. So you do groups of numbers that are called intervals. The rule is that the intervals must be of the same length. So 91 to 100 is 10 numbers, and so the next interval has to also cover 10 numbers, etc., etc. So you would see, okay, how many people scored from 91 to 100? So I have 1, 2, 3, I think that's it, 3. So you would do 3 for your tally and 3 for your frequency. And you would go on from there, etc., etc. Okay, another example is given to you here where it's already filled out for you. Sometimes they skip over the tally column. Okay, so this is an example of a frequency table that omits the column with a tally, which sometimes that happens, and you have to just be able to read them properly. So, for example, this row right here says that 250 people, because that's a frequency, earn between $22,000 and $32,000 a year. Now, frequency tables can get graphed into what are called histograms. A histogram is like a bar graph, except that your bars are touching one another. They're connected because the x-axis is continuous. The numbers continue, and you don't have to do the shading. That's something that people do for effect, but you just draw the bars, but you make them touch one another. Notice that the first bar represents $0 to $10,000. Sometimes your histogram, like in the next example, sometimes your histogram doesn't start at 0. Sometimes it starts at a value like 40. So if that happens, you have to leave a little space. See this little space that was left here on the x-axis? You leave a little space and you should put a break. A break is the little jagged line that looks like this, to represent that you're not starting at 0 for the first bar. So this is another example of a histogram here. Another type of way of organizing data is in stem and leaf plots. Below you have an example of a stem and leaf plot. This column is the stem over here, and these are the leaves. And what we do is we connect them to represent numbers. So this would be 44, 46, 47, 49. There are no numbers in the 50s, so that's why it doesn't have any leaves. 63, 64, 66, 68, 68. So it's a way of creating the list of numbers in a more organized way without having to repeat the tens digit every time. Another type of way of organizing information is in dot plots. So a dot plot just basically creates little dots, or sometimes you'll see X's to represent each value. So you could see like the frequency of number of people who take 5 minutes to eat breakfast is 1, 2, 3, 4, 5 people. Or there are only 2 people that take 8 minutes to eat breakfast. Okay. One important aspect of data that we want to know is we want to know, like, what's the middle, the central tendency, the measure of central tendency. What's the middle, the average? So we have 3 ways of describing the middle or the average. We have the mean, the median, and the mode, which you guys have learned about in the past. The mean is the sum of the data, sum of the values, divided by the number of numbers, which is the total frequency. Total frequency. The median is the middle value, but you have to make sure the numbers are in order to pick the middle number. If there are 2 values in the middle, if there's an even number of numbers, like if there's 8 numbers, then the 4th and the 5th numbers will be in the middle. If there are 2 numbers in the middle, then you find the average or the mean of the 2 middle numbers. And the mode is the number with the highest frequency. So in the example below, to find the mean, I would add them up and I would divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would add 5 plus 15 plus 10 plus 15 plus 5 plus 10 plus 10 plus 20 plus 25 plus 15, all of it divided by, what did I say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, divided by 10. The median would be the middle number, so if I ordered them first, 5, 5, 10, 10, 10, 15, 15, 15, and then 20 and 25. There are 10 numbers, so the 5th and 6th will be the middle ones. 1, 2, 3, 4, 5, and 6. These 2 are in the middle. So the average of 10 and 15. So if you added 10 plus 15 and then divided by 2, you would get 12.5. That's your median. And the mode is the number that appears the most. It turns out there are 2 modes. So you have what's called bimodal. Bimodal is when you have 2 modes. The modes are 10 and 15. Now the mean is, we say, sensitive to outliers. That means that if you have a score that's really, really high or really, really low, which we call an outlier, it will change the mean dramatically, more so than it'll change the median. Okay, so if you looked at the first example of a set of test scores, the median is 84, the mean is 83.4. If you look at the second set of test scores, somebody got a 0 on the test. And so what that does is it throws off the mean dramatically. Now the mean is only 79. So a class average, when people ask for a class average, can be brought down dramatically by an outlier, a really high or a really low score. But the median stayed the same. Okay? So we're going to look at some word problems that involve mean. I think I have to go to a new video because this is going to get too long.